Okay, this is a question from the textbook, page 288, number 18. So the question says, the social convener has 12 volunteers to work at a school dance. Each dance requires 2 volunteers at the door. So 2 at the door, 4 on the floor, and 6 floaters. Joe and Jim have not volunteered before, so the social convener does not want to assign them to work together. In how many ways can the volunteers be assigned? So we're given one restriction here, that Joe and Jim cannot be together. So this should remind you of those permutation questions where we group things together. So that's what we're going to do. We're going to, instead of saying Joe and Jim can't be together, put them together and then subtract that from the total number of cases. Actually, let's do the total no restriction case first. So ignoring that restriction about Joe and Jim, if we can simply put anyone anywhere, how many ways can we do that? So the first thing to recognize, there's 12 people to choose from, and we need to, let's do this first. We'll put 2 people on the door. So you have 12 people to choose from, and you're choosing 2 of them. You're putting 2 of them on the door. So this is the door. Action 2 will assign the people to the floor. So action 2, how many people do we have to choose from? Well, we had 12, right? We had 12, but then we just put 2 of them on the floor. So now we only have 10 to choose from. And then we're going to choose 4 of them. So this one was the floor. And now how many people do you have left to put as floaters? Well, there's only, we've assigned 2, we've assigned 4, so we only have 6 more. And we're choosing 6 of them. So this total no restrictions case, this one is going to be a fairly, well, it's not that big of a, so what is that? 12 choose 2, 66 times 10 choose 4, 210 times 6 choose 6, that would just be 1. So that's equal to 13860. I use a calculator for that one. Okay, so that's the total no restrictions case. So now let's look at sort of the indirect method. We'll group Joe and Jim together. So Joe and Jim are always going to be, together. Okay, well there's 3 ways they could be together. They could be together on the door, they could be together on the floor, or they could be together as floaters. So I'm going to have to do 3 cases. So case 1, Joe and Jim on door. Okay, so how many ways could Joe and Jim be on the door? Well, we'll go through a similar argument we did to here. So now we're first going to assign the people to the door. So to the door. Well, how many people do you have to choose from if you're putting Joe and Jim on the door? Well, you only have 2, right? It's got to be Joe and Jim, and we're choosing Joe and Jim. So there's 2 people we can choose, has to be Joe and Jim, and we're choosing them both. Second, the floor. So now how many people do we have that we can put on the floor? Well, there was 12 originally, we're not choosing Joe and Jim, so there's only 10 to choose from, and we're choosing 4 of them, times how many people do we have left to float? Well, there's 6 left, right? We've assigned 6, we've got 6 left, and we're choosing all 6. So that would be 2 choose 2 is 1. I'll put it in a bracket, times 10 choose 4, I did that up there, that was 210. And 6 choose 6, that one's 1. So there's 210 ways that Joe and Jim can be assigned to the door together. Case 2, Joe and Jim will be on the floor. Okay, we'll go in the same order. So we're going to assign the door people first. So I'm assigning the door. How many people do I have to choose from? Well, there's 12 people, but I can't put Joe and Jim on the door. So there's only 10 people I can put on the door, and I need to choose 2 of them. Then on the floor is the easy one because actually the floor is not that easy. So we're going to multiply that. The floor is actually tricky. You have to do it in 2 parts because well, Joe and Jim, well, you don't have to do it in 2 parts, right? 2 choose 2. This is me choosing Joe and Jim, but I actually need 4 people for the floor, so I need to fill in 2 other spots. I need to choose 2 more, and how many more do I have to choose from? Well, I can't choose Joe and Jim, so there's 2 people I can't choose, and I can't choose the people that I put over here, so it's going to be 8 choose 2 times, and then the floaters, and again, that'd be 6 choose 6, because there's 6 left, and we need to fill all 6 positions. Let me just move this over a bit. So what is that? 10 choose 2. So that would be 10 choose 2 is 45 times 2 choose 2 is 1. 8 choose 2 is 28. And 6 choose 6 is again 1. So 45 times 28. Let me grab a calculator. So I got 1, 2, 6, 0. And so that's case 1, case 2. Just gotta look at case 3. So Joe and Jim floaters. So they can be on the door, or sorry, we'll assign the door first. So people on the door, well, it's the same as this, right? It could be any of the 10 people who are not Joe and Jim, and we're choosing 2 of them, times on the floor. How many people do we have to put on the floor? Well, we've got 8 people now because we can't assign Joe and Jim, and we can't assign these 2 people, and we need to choose 4. We've got to put 4 people on the door, and then to float, well, again, it would just be there's 6 people left to assign, including Joe and Jim, but we got to assign all 6. So it's just 6 choose 6. Okay, so 10 choose 2, that was 45, times 8 choose 4, which I believe is 70, times 1. So again, grab a calculator. So I've got 3,150. Okay, so therefore the total ways Joe and Jim are together. So this is where we group them. We're just going to add up these 3 cases. So it's 210 plus 1,260 plus 3,150. So that's 4,620. So this is the total ways they are together. So therefore, the total ways they are not together is you're just going to go back to the original no restrictions case, 13860, and subtract the total ways they are together, and that will give you your final answer. So I got 9,240.